Hello everyone, and welcome to IS 300 and today's discussion of Chapter 2, ERP Architectures. In today's discussion, we will talk about some very important concepts. Enterprise resource planning systems are very commonly referred to as client-server architectures. Undoubtedly, you may have heard that term. We're going to delve a little more deeply into client-server architectures in this discussion. We'll talk about enterprise application integration. We will talk about two-tier, three-tier, and n-tier client-server architectures. We will talk about service-oriented architectures and or web-based architectures. And then we'll talk about cloud architectures, which is what CSI's Cloud Suite Industrial architecture is based on. And we will be specifically, in CSI, we will be using software as a service, which is a cloud-based architecture. At the heart of every enterprise resource planning architecture is a database. And the database, usually a relational database, will be provided by vendors such as Oracle or Microsoft SQL Server. Those are the two top database vendors, and you also have SAP. In our CSI Cloud Suite Industrial, we will be using Microsoft SQL Server back-end database. ERP systems rely on storage for master data, such as bill of materials, and for things such as transactions that are generated on a daily basis, or for data analytics. So if you are using transactional data, you are using what's referred to as an OLTP database, online transaction processing database, or if you're using analytics or business intelligence, decision support, you may have heard it referred to as any of those terms, then you will be using online analytical processing data. Both are stored on SQL Server databases in this case, and in our case, OLTP data is simply copied to the OLAP database for purposes of analytics and decision making. You may have heard those OLAP databases referred to as data warehouses. The master data will probably include the inventory, the product list, the prices, some financial reports, or financial reporting capability, maybe is a better way to put it, and any kinds of information that will be needed for generating and or creating orders through an enterprise resource planning system. That will be considered as master data. Any ERP system will have a client, a network, and a server. The network might very well be the internet, but you will still have client, network, and server. The ERP architecture will include two or more client-server processes. The clients will request a service, for example, invoicing a customer, a very common service that we will use in this class. The server then will respond to the client's request, gather the cost data, invoke an application that will maybe generate the invoice, generate a way for the user to see the invoice and to receive the invoice and to pay the invoice. Application servers then will enforce business rules and processing logic for the server, for the client's requests. The components of a client-server architecture will include the presentation tier or presentation layer. The presentation layer includes the user interface. It facilitates user input and output, and it provides a way for the client to send a request to the server. The data that's output, the output that is generated is part of that's displayed on the client computer through the presentation tier, maybe through a graphical user interface or a web-enabled user interface. The business tier will then manage the demand, handle client request, respond to the client request, validate that demand for accuracy, apply business rules. For example, the date must be greater than or equal to today's date. That would be an example of a business rule, a common business rule that would be included in the business tier applications. Communication through the network can either be push or pull. So the business tier can either send the request or receive the request. Push or pull simply means send or receive. Then the database tier. Again, every enterprise resource planning system will have a database tier, which handles the storage and retrieval. Database management system will be part of that. And again, we will be using as our database tier Microsoft SQL Server. We also, in enterprise resource planning systems, you may have a need for enterprise application integration, EAI, which allows for different systems to communicate with each other. So you may have different applications, multiple applications that are running in an organization, and those applications may not communicate with each other directly, but through middleware, which I would also refer to as a translator. The middleware can communicate, be the liaison, the go-between, if you will, between the various applications that are, for example, vendors, any partners in the value chain that would need to communicate through the enterprise resource planning system, and they don't speak the same language, if you will. And so you use the translator or the middleware to communicate with the different systems. It's a very ingenious way for multiple systems to communicate with each other. And for example, you might have a sale that generates a demand to place a vendor order. The vendor's system may not communicate with the sales system, but it can communicate through the middleware or through EAI. You may have procurement that generates demand for inventory updates or things like that, for putting pieces of the items together that are being ordered through a bill of materials. And so the procurement system then would talk to the inventory system through EAI. Then you may also have a need for you will have a need for financial planning systems to communicate with either the sales system, the procurement, all of these subsystems that are part of the enterprise that will impact finances and will generate reports and things like that through the financial planning system. And so you have middleware that can communicate with the financial planning systems that are in place as well. Here is an example. In this case, the yellow balloon is the middleware or EAI. The EAI can communicate, notice that the arrows go both ways, with a customer relationship management system, with a legacy ERP system. Maybe the ERP system is being upgraded, and so you have a new ERP system where all the data has to communicate through the middleware. You might have a third party, one or more third party systems. Supply chain management systems is what I would refer to these third parties as. You may have one or more websites that need to display this information from the ERP system using the middleware. And then you have the financial system, which is data going between both to and from the financial system to the middleware so that it can be retrieved by the new ERP system. That is basically the gist of enterprise application integration, also known as middleware. Then we have 2-tier, 3-tier, and N-tier client-server architectures. And again, a tier, just another word for a layer. So in a 2-tier architecture, the server holds the storage in the database. The client side component then connects and communicates with the server. The processing logic then is either handled on the server or on the client. If the client is a thin client, as in configuration 1, then the presentation logic is on the thin client, but the processing and the storage is on the server. Or vice versa, in configuration 2, if you have a fat client, then the presentation and the processing happens on the client side and the server is used for storage only. So wherever the processing occurs is considered the fat, either fat client or fat server. But the risk of using this type of configuration is that if you do not have control of all of the clients, then you don't know if they have the capability or the resources to handle the processing logic, which could become a bottleneck in your network, in your two-tier architecture. And so it is not widely used anymore. It used to be common back in the day, but it isn't that widely used anymore. Instead, here's an example before I go on to the three-tier. The database server and one or more clients that are connecting to through desktop applications. In this case, the desktop applications could be considered as thin clients, and the processing more than likely would happen on the database server. Okay, then we have three-tier and or n-tier. Three-tier architecture, basically you have multiple servers instead of just a single server. So you have a server for storage, say the server for the database, and you have one or more servers for applications, and you have a client-side component, or you could have an n-tier, which is just multi-tier architecture, which is more than 2 servers plus a client. And so we'll take a look at both of those. Here is an example of a 3-tier architecture. You have the presentation layer, where the clients reside. Clients can have one or more objects that they have generated, requests that are sent to the business layer. Business layer then can be running one or more applications or processes. Then the processes can interact between the business layer or within the business layer. And then you have the data access database layer, which provides resources back to the business layer, and the business layer then sends it back to the client on the presentation layer. You can also have an n-tier or multi-tier architecture, where you have the clients on one tier. These clients could be mobile clients, smartphones, mobile devices, and laptop computers, tablets, desktops, and so on. Then you have presentation tier, which is set up as a service. In this case, it could be a web-enabled presentation service that connects to a thin client that's running a browser, more than likely, some sort of browser that communicates with the presentation tier and provides services to, or provides communication rather, to the business tier, which handles the services of the business layer, validation, and business rules and things like that. Then you have the database tier. You may also have a directory service, such as LDAP, Lightweight Directory Access Protocol, or an Active Directory, if you're running a Windows environment, where the authentication occurs. So when the user logs on, when the client logs on, they connect first to directory services, they get validated, then they can access any of the information, access the services and or the database once they have been validated through the directory services database. You may also have a service-oriented architecture. Service-oriented architecture is a collection of services that are made available to an enterprise through a registry that acts as a directory listing. Services could be considered as a discrete unit of functionality that can be accessed remotely and can be acted upon independently. For example, validating a payment by credit card is a common example of a service that would be invoked. The registry that can be used to look up these services stores or uses a protocol called UDDI, Universal Description, Definition, and Integration. UDDI is like a directory which keeps track of all the services that are available and makes those services available to the various applications in the enterprise. Web-oriented, if the service is accessed through the web instead of through a traditional network, then it is considered web-oriented architecture. Here's an example of what used to happen before service-oriented architectures. They describe it as siloed, information silos. We talked about that in the first chapter. Monolithic, brittle. So you had redundancy because you had, in this case, you had several places where you would check customer status in the scheduling function and in the order processing function. You would check customer status. You would also determine the product availability in the scheduling side, and again in the order processing side. You would then check the order status in the order processing side, and again in the account management side. So you would have a lot of redundancy before service-oriented architectures. Once we started invoking service-oriented architectures, now you have reusable services. That is the key word, reusable services. That, for example, creating an invoice, checking the order status, checking credit, checking the inventory, and so on. Those services can be reused, and so you don't have to have multiple applications that are each one running their own set of services. Rather, you have reusable services that can be used by multiple applications and or multiple sales, customer relationship management, finance, data warehouse, and so on. Multiple modules can reuse the same services. Very efficient, makes perfect sense, and that is this is a good diagram that shows the difference between using service-oriented architectures and not using service-oriented architectures. The beauty of service-oriented architectures is that you have reusable services, no need to reinvent the wheel. Web-oriented versus service-oriented. That's not a either or. Simply service-oriented architectures have evolved into web-oriented architectures. So you have, they are self-service, they are easily consumable, they are integrated. In the case of service-oriented, they were aging heavyweight standards. Now they are lightweight web standards. They are distributed, and so on. You can see the evolution, I guess, is a good way to put it. Then we talk about the cloud. The cloud architecture goes beyond web-oriented architecture and says that any object might be tagged and connected through the internet. The National Institution for Science and Technology defines cloud computing. Here is the definition: on-demand network access, shared pool of configurable computing resources, network servers, storage, applications, and services, rapid provisioning, minimal management effort on the service provider, promotes availability. 5 essential characteristics: on-demand, self-service, broad network access, resource pooling, rapid elasticity, which means it's very scalable, measured services. And then there are cloud service, software as a service, which is what our Cloud Suite Industrial is based on. We have platform as a service, which provides the ability to provide, for example, platforms such as Microsoft Windows or iPhone. iCloud is a good example. Cloud infrastructure as a service, IaaS. You also have deployment models: private, public, community, or hybrid. So if you would like to look at the official definition in detail and read about the National Institute for Science and Technology standard for cloud computing, there is a link to the website there. The advantages of the cloud: it is agile, it's easy to grow, and very flexible. You can rapid deployment is a good strong benefit of cloud architecture. It is scalable. It can scale up, or usually it doesn't scale down, but it could if necessary. The disadvantages of cloud architecture: security, which is a challenge. Of course, it becomes more of a challenge because you have multiple devices interacting through the cloud, and those devices may or may not have robust security in place. So your security is only as good as the clients that are connecting to the cloud, and it is a big problem. But it is a problem that can be solved through encryption, authentication, and things like that. Interoperability: usually you can get around the interoperability issues by making sure you have some either middleware in place or a way for multiple disparate systems to communicate. Profitability: cloud can be expensive if it is not properly implemented in the first place, and if you do not have the appropriate level of expertise running the cloud system. That's usually can be a very big problem. Here's an example of the cloud. You have, again, your clients, mobile clients, PCs, or phones connecting through the internet to software as a service, which we will be doing in this with Cloud Suite Industrial, infrastructure as a service, or platform as a service. You can also have hardware as a service. So you can, if our Infor CSI architecture is a cloud-based service-oriented architecture, and hopefully now you know that that means reusable services that are made available through the cloud. It is hosted by Amazon Web Services. It augments Amazon Web Services security for cloud deployments. And you can implement this architecture either on-premise, at the customer premise, or through the cloud, or both, depending upon what the customer requires. And as I mentioned earlier, we will be using Microsoft SQL Server and a .NET platform. It is very user-friendly. The applications that are running on a .NET platform are very familiar. They use the Windows interface, which we are familiar with. Those of you who are Windows users have seen this interface. All of their applications use the same Windows interface. Flexible, scalable. Those are the benefits of the CSI architecture that we will be using this semester. It includes manufacturing, project management, supply chain management, finance management, human capital management, which is interesting, human resources in other words, design, engineering, materials management. All of these are very familiar to us, or they will become very familiar to us this semester, and they are all available through Infor's Cloud Suite Industrial. I have made available a link if you would like to look at Infor's Cloud Suite Industrial. There is a link to some videos and some slides that will give you a good deal of information about CSI. And again, we will be using CSI this semester, so you will get an opportunity to become very familiar with it. Okay, so here's our review. Three-tier architecture includes web servers, storage servers, client-side components, application servers, service-oriented architecture. It could include all of the above. You can, it doesn't necessarily have to include web server. Could be an in-tier architecture, and then maybe there's a web server. So I would argue that it could be all of these, or it could be B, C, D, and E. Depends on the configuration. That's kind of a trick question, I guess. Infor CSI architecture is characterized as A, cloud-based service-oriented architecture, B, one tier, C, two tier, or D, three tier. Of course, that would be A, cloud-based service-oriented architecture. That has been our discussion of Chapter 2, Enterprise Resource Planning Architectures.